So here's the i.MX 6. We're launching here at the FTF 2011. So what does it do?
Well, first of all, welcome to the Freescale Technology Forum. We're happy to have you here. What we're announcing this week at the Technology Forum is the first live demonstration of the i.MX 6 application processor. And what that is, it's a quad-core application processor that we announced back at CES. What we're showing here today is the first reference design that we have available for i.MX 6. And as you can see here, it's doing two different things. We have one aspect of it where it's driving 1080p video. The video unit on here is capable of up to dual stream 1080p for use models like 3D decode and 3D encode. We also have the i.MX 6 driving graphics, and what's really unique about this is we've only had silicon back for a week. And so this is literally 7-day-old silicon. We got the video unit running in the first 24 hours, the graphics unit running in the first 48 hours. We've now booted Linux, Windows CE operating systems, and Ubuntu, and the bring-up has been going phenomenally well.
So you announced 6 months ago. What is the work process to design a processor like this?
So a lot of stuff involved. You know, from a silicon standpoint, there's a lot of RTL that has to be designed. We're using a lot of blocks that are different from what we've had in previous generations. There's a lot of back-end layout work in terms of taking all the RTL, putting it together, and then of course you have the fab cycle through the fabrication plant where you actually make the thing. And then once it's out, then it's all in the hands of the software guys. So we have multiple teams inside of Freescale that are involved with porting various operating systems like Linux, Android, Ubuntu, and Windows.
So is this the first revision of the board with the CPU on it, or how do you put it on?
So we have a special socket that we have on our board here today, and so the silicon is actually underneath the socket, and this is a reference design that we will make available to our early customers, and it's a pretty simple procedure just to get the silicon on board.
So what can you announce, what can you say about the memory bandwidth, the graphics, and all these advanced things?
Sure. So this is the industry's first SoC that has a quad-core ARM CPU combined with a full 64-bit memory bus. And the reason that's important is as you look at the different applications that are being developed in the consumer, embedded, and industrial and automotive spaces, what you find is that there's a exponentially increasing amount of demand on the CPU for more megahertz and for graphics for more complex graphic implementations. And really, in order to realize that benefit of those massive increases in capability, you have to balance the system with more memory bandwidth, otherwise you're going to bottleneck it. So in addition to that, we've added in a lot of interfaces for the consumer segment, the embedded segment, the automotive segment. We've also been qualifying the device for the different segments, so we have industrial qualifications, consumer qualifications, and automotive qualifications.
So what does it mean when you say 64-bit memory bandwidth? Is that anything related to what people are asking of ARM to be 64-bit? Is that another question, or is it actually that you're solving?
It's actually a little bit different. So the width of the CPU itself, today ARM CPUs are 32 bits, is somewhat independent of the memory bus bandwidth. So typically most application processors today are 32-bit. If you go buy an x86 machine for your desktop PC, typically 64-bit, and we're migrating the memory interface to 64 bits now.
All right. What can you say about the graphics that's going on here? What is that?
The graphics that we have, we actually are running the graphics on what we call the Freescale triple play graphics architecture, and this actually consists of 3 physically separate graphic units. The first is a 3D unit capable of up to 200 million triangles per second. That's a 6x improvement over where we were the last generation. We also have a second 2D engine. The 2D engine is a vector graphics engine, and you can use that for things such as driving the needle on your automobiles, gas gauge or speedometer. And then we have a third 2D unit that's in there for blit operations, which is often used for user interfaces. So having these 3 physically separate engines really allows designers to fully optimize for latency and performance.
So you have did you announce the process size?
So we're using, all these chips are using the 40 nanometer process.
And so you have a space where you have to put all your stuff on that chip somehow, and So the Freescale is the 3D, the graphics is a Freescale technology.
So we don't say exactly where the technology comes from. All of the technology internally is either developed in-house or licensed through partners. In the case of the graphics, we're actually partnering with a company called Vivante Technology. And so Vivante is our graphics partner in the case of i.MX 6.
And you said 200 million polygons, so triangles per second?
Correct.
And that's similar to kind of like a PlayStation 3. It's like crazy.
It's console style gaming. And so I think, you know, when you look at some of the applications being designed over the next few years, a lot of these applications are really going to take advantage of console style capabilities, whether it's for gaming or other types of applications.
So where do you see it go? This is like, it looks like a tablet kind of form factor, but it could be what?
Correct. So, you know, we see this proliferating across a really wide variety of segments. So starting with smartphones, looking at web tablets, smart books, automotive infotainment systems, and then we have a very wide business in the industrial space where we literally have hundreds and hundreds of applications being designed, things from home energy gateways to e-readers to other types of devices.
So how soon can you announce Honeycomb and Windows 8 support?
So we certainly are working with Google on Honeycomb, and we will be announcing what we have there at a future date, but we're very optimistic about providing support for Honeycomb as well as other operating systems in the industry.
So during the keynote you announced that it's actually going to be in products in 2012. Mm-hmm. 2011 you can't hurry. You had to hurry for FTF already to show, but you can't make it in products before Christmas, right?
Absolutely. We're excited to have this stuff in silicon right now. It's been, as you mentioned, a week since we've had first silicon. Normally these design cycles take a while in terms of in terms of finishing the product for production. We won't be there this year, but we'll certainly be there in 2012.
And so you said 7 days. What if there was a little bug or something? That would have been terrible, right? You couldn't have shown it here at FTF.
That would be. I've been doing this for a number of years now, and I would say this is by far the best silicon bring-up that I've ever witnessed and I've ever been fortunate to be part of. So things are going great.
So to make it into mass production, you have to still test and still do bug fix? Or what's the process?
It's a very normal type of cycle. So what happens is our software guys will get to the silicon, they'll really test out all the major capabilities of the silicon. We'll start to port different operating systems, and as you design silicon, oftentimes you might find some issues, you may not find issues, and you address those as you go.
All right, and right here you're showing kind of like it is a real demo, but no interaction right now. No touch or no keyboards or mouse or anything. You could, but you're not really doing it right now?
We could have done that in the case of the Freescale Technology Forum here this week. We wanted something that was relatively simple to set up and easy to demonstrate, and so we chose to really focus on the video and graphics capabilities of the system.
All right, thanks a lot.
Okay, thank you.
Chairman of the Board and Chief Executive Officer, Rich Lyon.
For joining us. Welcome to the 2011 Freescale Technology Forum. Significant amount of software that enables you, based upon our solutions, to bring your products to market more rapidly than you otherwise might be able to do. This mobile internet is driving massive IP traffic growth. By 2015, research studies indicate that IP traffic generated by wireless devices will surpass the traffic generated by wireline devices. We will need mobile operating system compatibility across many devices, design scalability to be able to provide these devices at a constantly increasing rate, and to lower the overall cost of these devices. Analysts predict that performance of mobile processors could already in 2012 surpass the performance of PC processors. To meet these demands, Freescale in January at the Consumer Electronics Show announced our new processor family, the i.MX 6 series, and 6 months later, we are pleased to announce that we have working silicon ready for sampling to our customers. And we want to give our FTF attendees the first look at one of the industry's first ARM-based quad-core multimedia apps processors. And to help me do that, please join me in welcoming Freescale Product Line Manager for the i.MX, Rajiv Kumar. What do we have today?
I'm thrilled to be here today and be able to have the privilege to talk about our next generation i.MX products, specifically the i.MX 6. And what I've actually got here is a wafer that I took out of the fab on my way out. And, you know, it's interesting, I don't think my engineering manager is too happy with me taking this out. And it's got a few thousand die on here. I figure it's upwards of $60,000 plus. I'd actually feel a bit more comfortable if you held on to it today.
I'm not sure I should be holding it either.
So as you mentioned at CES this year, we announced our i.MX 6 series of products consisting of a quad-core, dual-core, and single-core product portfolio. We also stated, as you mentioned, that we would be sampling first half of this year. I am pleased to announce that we have first samples, and on stage here behind us we have our first public live demonstration of i.MX 6. You want to check it out?
Yes, let's go look at it.
So i.MX 6 represents the industry's first SoC that combines 4 cores of ARM CPUs with a full 64-bit memory bus. And the reason that's important is because as you look at the breadth of applications that are being developed in the consumer, automotive, and industrial market segments, what you find is a exponentially increasing demand for CPU horsepower and graphics horsepower. Now, the massive improvements we made in these areas on our chip is great, but it's not sufficient. So you want to make sure that as you add capability to the chip, you don't bottleneck your chip with overall system performance. And a critical aspect of that is really memory bandwidth across the memory bus. So that's been the primary motivator for us to move to a full 64-bit memory channel and what we've implemented on i.MX 6. And so what we have here is our reference design for i.MX 6. As you can tell, it's got a couple HDMI cables coming out of it. The first one is connected up to the TV. What we have coming up on display on the TV will be a 3D graphics game that will be generated from the reference design. The game some of you might recognize as being Quake, and it should come up here in just a moment. Here we go. Quake is a game that often is used to benchmark frame per second performance on early silicon. And as you can tell by the demonstration that we have up on here, we're getting quite good performance on our silicon and our graphics unit. The game here is actually running on what we call the triple play graphics engine. What that is 3 physically separate graphic units that are incorporated within the chip. The first is a full 3D graphics engine that's capable of up to 200 million triangles per second. That's a 6x improvement over where we were in the last generation of products. We also have a second graphics engine, which is a 2D vector graphics engine. How you might use this would be, for example, digitizing the dial or the needle, if you will, within the speedometer or gas gauge of automobiles. We have a third engine in there, which is a 2D blit engine, and that's primarily used by a lot of operating systems to do UI acceleration. And so as the UIs continue to evolve over the next few years, becoming more and more interactive, more and more complex, we see that driving a very strong need to be able to accelerate on a dedicated blit engine. And having these 3 engines in place really allows you to optimize overall system performance for both power as well as latencies that are through the system, and you don't compete with a specific silicon resource when you're looking to do multiple things at once. So next, what I'd like to talk about a little bit is video performance on the system. And the next demonstration we want to show is video running on the reference design. And so coming up here, we have a video clip that will be playing in full 1080p resolution. And the clip, if you pay a little bit of attention to it, really talks about some of the innovative new use models that we see coming to market over the next few years, and ones that i.MX 6 will be able to drive. The video unit itself is capable of driving up to 1080p, 60 frame per second resolution video. It can also drive dual screen 1080p full HD class video for 3D use models. So if you want to do 3D decoding on your device or 3D encoding, you have that capability now with this chip. Now, what's really cool about this is you can tell from the device itself, we actually have 2 HDMI cables coming out of this. So we're driving both the video and the graphics simultaneously on the chip. The chip is only 7 days old, and so we're, bring up is going phenomenal. We had the video running within the first 24 hours of seeing silicon in our labs. We had the graphics unit up and running within 48 hours of seeing silicon. And just in the past week, we've got the Linux kernels, Windows CE kernels, and a full Ubuntu OS booting on the system. Again, bring up has been going phenomenal. Now, very much related to video performance is display. And as you look at how display technology is evolving in the industry, what you're going to see over the next few years are devices in market that are at least 4x the amount of resolution over best-in-class screens that are in market today. In order to keep up with that pace, what we've done is we've completely re-architected our display path. And within the i.MX silicon, what we have is the ability to support up to 4 simultaneous screens, 2 of which can be driven up to quad XGA resolution. So if you do the math, that's roughly 4x the amount of pixels that you have versus a single 1080p HD screen. Now the other aspect which is important is overall peripheral integration. And the reason peripheral integration is important are really for 2 reasons. One, you want to have the flexibility to be able to interface to other things on your device. And 2, you really want to be able to drive down overall system cost. And one of the best mechanisms to do that is by integrating more things onto the processor itself. So in support of that, what we've done is we've integrated an industry-leading amount of peripherals onto the chip. We have interfaces such as MIDI, USB, SDIOs that are used in the consumer space. We have interfaces such as MOS bus and CAN controllers, which are critical for automotive applications. We have interfaces that are traditionally compute-oriented, things like PCI Express, serial ATA, and gigabit Ethernet, and all of those have been packed onto the single die within the i.MX 6 SoC. Now, in addition to that, as Rich talked about earlier, it's very important that you be very mindful of power and total system solution. So when you look at the video that's being played back on this chip, full 1080p video runs at less than 400 milliwatts within the SoC. We also have taken care from a board level and a software level to tightly couple other Freescale products within our solution, such as the Freescale sensor products, as well as the Freescale power management, system power management products. So all of those will be delivered to customers. We're engaged with many customers today, and Rich, just to wrap up, I fully expect to see devices in market in 2012 really spanning a wide gamut of products, so things from smartphones to web tablets to smartbooks, automotive infotainment clusters, and literally hundreds of applications in the industrial space.
So we're sampling at the moment, and when do you think we're going to see a broad range of products coming out?
We'll start to see products come out starting in 2012 next year.
Very impressive. Very cool. Thanks very much. Appreciate it. Tell the team we did a really, really fine job.
I will. One more thing. I just got the signal that we have to package up a few more parts, so we'll leave the week.